In this video, we will do some trig function multiple choice review problems. These will draw on our knowledge from topics 3.1 through 3.10. If you appreciate the content, please give it a like. Number 1. The function g is given by g of theta equals the tangent of 2 pi theta. Which of the following statements about the graph of g in the xy plane is true? We notice that all of the answer choices are about vertical asymptotes. And we also know that tangent is equal to sine over cosine. So the tangent of 2 pi theta will equal the sine of 2 pi theta divided by the cosine of 2 pi theta. The vertical asymptotes will occur whenever a trig function is undefined. And that's going to be when the denominator is equal to 0. That's why we need to solve cosine of 2 pi theta is equal to 0. The solution to this equation will be where the vertical asymptotes are. We begin by solving for what's inside the trig function. To solve for 2 pi theta, we ask ourselves the cosine of what is equal to 0. In other words, where on the unit circle is cosine equal to 0? We know that cosine is the x value on the unit circle, and x values will equal 0 here and here. That's at pi over 2 and 3 pi over 2. These are the solutions on the interval from 0 to 2 pi. However, there is no limit on the domain, so we need an expression for the infinitely many solutions, not just a list on a limited domain. When the solutions are directly across from each other like this, we can get from one solution to the next by adding pi radians. So we can write an expression for the infinitely many solutions by starting with one solution, which is pi over 2, and then adding multiples of pi. In other words, by adding pi k, where k is any integer. We just need to do a little bit of algebra to get theta by itself. So on the next step, we're going to divide each one of these terms by 2 pi. So we're dividing by 2 pi here, here, and here. So these will cancel out, and we are left with theta on the left-hand side. When you divide, this is a quick little side lesson, if I have a over b, and then that is in turn divided by c, what happens is the extra c winds up in the denominator. So I have a over b times c. So if I want to divide pi over 2 by 2 pi, I'm going to have pi over 4 pi, because this 2 pi is just going to come up and multiply the denominator. So we have pi over 4 pi plus, and I'll just recopy this for a moment, pi k over 2 pi. So these pi's will cancel each other out. So we have theta is equal to 1/4, and I can either, these pi's cancel each other out, so I have k over pi, or I could write 1/2 k, where k is any integer. So I'm going to keep this on the screen. We are looking for 1/4 plus 1/2 k. And there it is. So the answer is B. Number 2, the graph of function h is given in the xy plane. If h is equal to a times the tangent of bx plus 10, where a and b are constants, which of the following is true? And there's some information about whether a is positive or negative, and whether b is bigger than 1 or between 0 and 1. Let's start with a because that is easy. The parent function, tangent x, is always increasing from left to right, just like these are. So when we are looking at a transformation of the tangent function, if the little waves are increasing from left to right, we know that we are dealing with a positive a value. It matches the parent function. It's not upside down. In other words, if I saw a transformation of the tangent function that was doing like this, decreasing, this is when the a value would be negative. But increasing means the a value must be positive. So we can forget about options C and D. Now we can focus on the b value. For the tangent function, we know that the b value is pi divided by the period. So let's figure out what the period is real quick. The period can be measured from point of inflection to point of inflection. So that's from 0 to pi over 2. Therefore, the period is pi over 2. That means the b value is going to be pi divided by pi over 2. When you divide by a fraction, you multiply by the reciprocal. So b will be pi times 2 over pi. These pi's cancel, leaving b equal to 2. This is clearly greater than 1, so the answer must be A. Number 3, let g be the function defined by g of x equals this expression. Which of the following gives the vertical asymptotes to the graph of g? Vertical asymptotes will occur wherever g is undefined, and g will be undefined wherever the tangent of x over 3 is undefined. Remember, the tangent of x over 3 is equivalent to the sine of x over 3 divided by the cosine of x over 3. Tangent is sine over cosine. So the question is, where is this expression undefined? Well, that will be wherever the denominator is equal to 0. So we can find the asymptotes by setting cosine of x over 3 equal to 0 and solving. First, we solve for what's inside the trig function. We have to solve for the x over 3 part. And we do that by asking ourselves, the cosine of what is equal to 0? In other words, where is x equal to 0 on the unit circle? Well, we answered this question before, so I'm not going to repeat all of that. We know that cosine is equal to 0 at pi over 2 and 3 pi over 2. And furthermore, we remember that we can get from one solution to the next by adding multiples of pi. So we're just going to do the one solution at pi over 2, and then we add multiples of pi. So we add pi k, where k is any integer. We just need to do a tiny bit of algebra to get x by itself. So we are going to multiply everything by 3, here, here, and here. So that's why the final answer is going to be x is equal to 3 pi over 2 plus 3 pi k, where k is any integer. Hold that in your head, 3 pi over 2 plus 3 pi k. And we see that right here. So the answer is C. Number 4, let f of x equal this expression, and let g of x equal this expression. In the xy plane, what are the x-coordinates of the points of intersection of the graph of f and g on the interval from 0 to 2 pi? The intersection points will be where these two functions are equal. So we need to begin by setting these equal to each other. So we have negative radical 2 plus 5 sine x is equal to 7 sine x. So I'm only seeing one type of trig function. We just have the sin x. These are like terms. So we should be able to combine these by subtracting 5 sin x from both sides. So I'm going to have negative radical 2 on the left side. 7 sin x minus 5 sin x is 2 sin x. Next, we will isolate the sin x by dividing both sides by 2. So on the left side, we now have negative radical 2 over 2 is equal to sin x. I'm just going to flip this around. We can solve for x by asking ourselves the sine of what is negative radical 2 over 2. First, I'm going to really ask you, what is the reference angle here? What am I talking about? Hopefully you memorized these 9 trig facts long ago. If not, pause the video and memorize this chart right now. Practice writing it on a sheet of scratch paper without looking. These angles across the top are the reference angles I'm talking about. We're trying to solve the equation sine x equals negative radical 2 over 2. Ignoring the negative sign, we ask ourselves the sine of what is radical 2 over 2. And looking at the chart, we know the sine of pi over 4 is radical 2 over 2. So pi over 4 is the reference angle. Sine is the y value on the unit circle. So since we need sine to be negative, that will only be in the quadrants where y values are negative. So quadrants 3 and 4. If the reference angle is pi over 4, that means the size of this angle and this angle are both pi over 4. So what will be the measure of these angles if we go, all the way from positive x all the way around, like this or like this? Well, I like to think of it this way. We can think of pi as 4 pi over 4. So this angle right here in the third quadrant is pi over 4 more than this. So that'll be 5 pi over 4. And if this is 4 pi over 4, then double that is 8 pi over 4. So this angle right here is pi over 4 less than that. So that is 7 pi over 4. So that's it. These are the x-coordinates of the two intersection points of f and g on the interval from 0 to 2 pi. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.